The determinant of an n by n matrix can be calculated as the sum of a row or column where the entries have been multiplied by their cofactors. This is the mathematical interpretation of that statement. A1j C1j plus A2j C2j plus A3j C3j. That would be for a column A1, A2, A3, A1j, A2j, A3j, and their corresponding cofactors. And this would be for a row. AI1, AI2, AI3, that would be going along here. So the entries multiplied by their cofactors all added together. So to find a cofactor, I go to a corresponding entry, A11. I want to know what the cofactor for this is going to be. I eliminate the column and the row, and I take the determinant of the remaining matrix. For this, since it's a 3 by 3, the remaining matrices will be 2 by 2. If this was originally a 4 by 4 matrix, then I would be left with 3 by 3 matrices. So the determinant of this would be the corresponding cofactor, and the cofactors can have different signs, but forget about that for a second. So for A11, this would be the cofactor, the determinant of this. For A12, eliminate the column and the row, and this matrix, A21, A23, A31, A33. Find the determinant of that. There's a sign that goes along with it. Don't worry about that for now. Just have a look at how to get the cofactors. For A13, same thing. Find the determinant of this. That's going along a row. Doesn't matter what row it is. I can go along this row. So here's a matrix, 4 entries, like this. There's that matrix, like this. Of course, it can be a column as well. It doesn't matter if it's a row or column. I always just pick the top row. It's the easiest way to do it, but it can be any row or any column. So let's look at an example. So to figure out the determinant for this 3 by 3 matrix, the rule says, up again, the sum of a row or column where the entries have been multiplied by their cofactors. So I pick a row or column. I always pick the top row. And what I need to do is multiply the entries by their cofactors and then add them all together. So for the top row, A11 times this determinant. And here's what the signs for the different cofactors are going to be. So for A11, it's going to be positive. A12, it's going to be negative. A13, positive. It keeps alternating positive and negative as it goes across the row and down the column. So it's pretty easy to remember. So this cofactor is the determinant of this matrix right here. A22, A23, A32, A33. So A11 times the determinant of this, and it's positive. So that's the first one. And it's the sum of either an entire row or an entire column. As I said, I always do the row. It's just the way I do it. So plus the next one, A12 times the determinant of this, and this cofactor is going to be negative. So A12 times the negative determinant of A21, A23, A31, A33. And then lastly, A13 plus A13 times the determinant of A21, A22, A31, A32. And this one is positive. That's for a 3 by 3. It can be done for any size matrix.